Now, in the method of sections, we will take equilibrium of a section of a truss and find the member forces. That is why it is called method of sections. Then why should we take a section of a truss is, the advantage is that we can find forces in any intermediate member also directly without finding forces in any other members. Okay. So, that is the advantage of the method of sections. Equilibrium of a section of a truss is considered in method of sections. Then what is the advantage? The advantage of method of sections is that force in any intermediate member can be found directly without finding forces in any other members. This is the advantage. Once they ask it as a 2 marks question, what is the advantage of method of sections? One of the options is this, we can find without finding forces in any other members. Then what is the procedure? As in method of joints, here also a 2-step procedure, each step will take 10 to 15 seconds time, 30 seconds we can complete the problem. First step, find support reactions by considering equilibrium of entire truss. It is like external equilibrium equation, sigma x, sigma y, sigma m is equal to 0 without cutting the members or without separating the joint. Come outside the structure, find the reactions. Okay, that is what. Second step, cut the member under consideration by a section 1-1 and consider equilibrium of either left hand side of 1-1 or right hand side of 1-1. Cut the structure, cut the truss such that your member should be cut. Okay. Cut the member under consideration by a section 1-1, then equilibrium of either LHS or RHS of 1-1 and use sigma x is equal to 0, sigma y is equal to 0 and sigma m is equal to 0 to find the unknown forces. This is the process. In the process of this one, when you are cutting the member, what are the precautions we have to take? Those precautions I will write. First precaution is this one. Cut the member such that entire truss is divided into 2 separate parts. any member you are asked to find, you cut such that the truss must be split into two parts. Then one part you can throw it, another part you can consider for the equilibrium. Second point is, cut the member or preferably means as far as possible, preferably don't cut more than 3 members, because in method of sections we have only 3 equations of equilibrium. What are they? Sigma x0, sigma y0, sigma m0. So with 3 equilibrium equations, we can only find 3 unknowns. That's why we should cut only 3 members. Don't cut more than, as far as possible, don't cut more than 3. Exceptions we will see later. Then third point is, cut the members such that all the cut members do not meet at one point. So what happens if they meet at one point? Sigma m is equal to 0 becomes useless equation. And it becomes method of joints problem. It becomes a method of joints problem. That is the difference. Once all the members meet at one point, sigma m is equal to 0 is equal to 0, then it is a method of joints. So it is, that's why method of joints is a particular case of method of sections where the cut members meet at one point. If they don't meet, it becomes method of sections. Okay. These 3 points we have to keep in mind when you are cutting the member in method of sections. Let us see how to make use of those 3 points in our problems. Now you see, we want to find force in the member BC, let us say. That BC member is something like this. This is A, B, C, D, this is say E. Assume that there is a load of say 10 kilonewton. This distance, let us say 3 meters. This is also 3 meters. Height also, let us say 3 meters. Okay. So we want to find force in the member BC. Now you see, what is the first step? As in the earlier problem I told you, first step is to find the support reactions. Whether the structure is symmetrical or truss is symmetrical or not, If the loading is symmetrical, support reactions will be equal. They will share the applied load equally. So, from this you will get VA is 5, VD is also 5. To find this, it hardly takes 5 seconds time, what the support reactions are. Next, second step is what? Cut the member under consideration by a section 1-1. So, you must cut the member BC such that entire truss is divided into two separate parts. Cut the member such that entire truss is divided into two separate parts. So, you cut the member BC such that it is split into two parts. Now, see, you didn't cut more than 3 members. All the cut members are not meeting at one point. These two are meeting here, but these two are meeting here. So, all conditions will be satisfied. Now, you can take equilibrium of either LHS of 1-1 or RHS of 1-1. We will consider, let us say, equilibrium of RHS of 1-1. If I take equilibrium of RHS of 1-1, we can take LHS of 1-1 also. Whichever side is easier for us to analyze, that side we will take it and complete the problem fast. Okay. So, cut here, you can take LHS or RHS. Since you are taking a section of a truss in equilibrium, it is called method of sections. So, we will cut here, throw this piece out, consider this one. Now, that looks something like this. Okay. This point is C, D, this is VD, it is 5 kilonewton. Now, this is free body diagram of RHS of 1-1. This RHS of 1-1 looks something like this. Now, free body diagram means it is the diagram of a body on which what others are doing you have to show. So, what these 3 members will do on these 3 members you have to show here. We don't know whether these 3 members here are pulling the members or pushing the members. So, let us assume that all of them are getting pulled. So, force in the member BC, force in the member CE, force in the member DE, CB, CE, DE, like that. So, these are the 3 arrow marks are the forces exerted on the pins by the LHS of 1-1. Assume that it is getting pulled. Now, these CE and DE members are meeting somewhere in air. Now, this length is 3 meters. This height is also 3 meters. Okay. Now, we are interested only in the member BC, not interested in the 2 members. The unwanted members we don't want to deal also, because we have only 1 minute time. We have to find BC and get out. These 2 members we don't want to find. So, you must take an equilibrium equation such that these 2 forces will not come in the equation at all. Then such cases, if I take these 2 members where they are meeting at E, if I take moments of all force support point E in the air, now when I am cutting it here and throwing this piece out, and the 10 kilonewton we should not keep it, because you cut and throw it into dustbin say. Again from the dustbin you cannot take the 10 kilonewton and hang it in air, it will fall down. So, that piece is not available, but moment center, as you have learned in engineering mechanics, moment center can be anywhere in air also. Moments of all force about that point in air also should be 0. About a point in air, bending moment may not be there because there is no member to bend, but rotational effect will be there. Simply force into distance is called rotational effect of a force. That rotational effect, if it bends the member, it is called bending moment. If it twists the member, it is called a twisting moment. If it does not do anything, no bending, no twisting, simply rotational effect. That is all. External rotational effect of a force about any point is called moment. If at all it bends, it is called bending moment. If at all it twists the member, we call it as twisting moment. Now, no bending, no twisting, some simply external rotational effect we are finding. So any point in air we can take it. So take moments of all force about some point in air, sigma me is equal to 0. So if I take sigma me is equal to 0, moments of all forces, clockwise positive, anti-clockwise negative. Now FBC travel from tail to the head towards E, anti-clockwise. So you will get minus FBC into 3. These two forces give 0 moment. 10 is not there, so they don't have to write. Then VD, travel from tail to the head towards E, again anti-clockwise. So minus 5 into 3 is equal to 0. So you will get FBC is equal to minus 5 kilonewton. See, these arrows arbitrarily you assumed. You don't know whether the members are getting pulled or pushed. Some arrow mark you have taken. If the result works out to be negative, our assumed direction is wrong, so we have to change the direction. So here negative sign implies that our assumed direction for FBC is wrong. So arrow must be towards the joint. Arrow you assumed away, so it cannot act away, it must be towards the joint. So FBC is now nothing but 5 kilonewton. Towards the joint means what? Compressive. Like this. So you are getting here minus. Minus implies that assumed direction wrong, you have to change the direction, which means that 5 kilonewton compressive. That means in this problem now when you are taking, you have to write now 5 towards the joint 5 kilonewton. Here if it is towards, here also it should be towards the joint. Like that we have to find. Now in this one, it is a 2 marks question. You have 1 minute time to find the solution. When compared with this problem, here what extra is there in this entire free body diagram is only these 3 arrows. Those 3 arrows here itself we can show, and you can skip this one. If you get negative sign, so much story you needed to write. Supposing that if you don't get negative sign at all, you put the arrow mark such that we will not get negative sign. Then this write up also is not required. Then how to decide? So next problem we will not write this diagram at all, because the 3 arrows here itself we can keep it and find the solution. Now you see, to avoid this arrow mark, you will do like this. Cut here by 1 1. We are not interested in these 2 forces. We want only this one. Now this anyhow they don't give any moment about C. So now here only one force is there, VD. Travel from tail to the head towards E, anti-clockwise. To balance this anti-clockwise movement, it has to be clockwise. So put arrow mark such that it will give clockwise movement. Question of negative sign will not be there at all. Okay, so that's how we'll fix it. Anti-clockwise about E, clockwise about E. So arrow mark directly we can fix it. Correct arrow mark itself. So your FBC is 5 kilonewton. Okay. Now instead of cutting it like this, if you cut it this way, this also we are separating it, 2 separate parts. But all the cut members are meeting at C. If they meet at C, if I write sigma MC is equal to 0, then 0 is equal to 0 it will become. See, if I cut this way, sigma MC is equal to 0 means what I will get? 0 is equal to 0. Now it becomes like a method of joints problem. That's why you have written cut the members such that all the cut members do not meet at one point. If they meet at one point, it becomes method of joints. The difference between method of joints and method of sections is only that, how you cut them. Cut like this separate, method of joints. Cut like this and separate, method of sections. So method of joints is a particular case or a special case of method of sections where all the cut members meet at one point. Okay. Preferably don't cut more than 3 members. Means if you cut horizontally like this or this way, 1, 2, 3, 4, 5 members you cut them. Then what will happen is we have only 3 unknowns, 3 equations of equilibrium, 5 unknowns you cannot find. So don't cut more than 3 members as far as possible. Okay, so all the 3 conditions satisfied. So next problem we will see that this free body diagram we will not draw, we will not get negative sign. Okay, now assume that now instead of BC member we want to find force in the member CE. This part I remove now. Now we want to find force in the member CE, let us say. The next question. This point say A, B, C. This point is a D, E. This load again same 10 kilonewton. This distance 3 meters. This also 3 meters. Now assume that this angle of inclination say 45 degrees, so height can't be 3 meters. Now we want to find force in the member CE. Now I will read out all the 2 steps procedure. First step is to find the support reactions. Because loading is symmetrical, reactions are equal. So VA is 5, VD is 5. So first step is over, 5 seconds. Second step, cut the member CE by a section 1 1. So I will cut like this. And this is a process. Cut CE by 1 1. Then again take equilibrium of, this equi means equilibrium of RHS of 1 1 I will consider. Then I will use sigma y0, upward positive, downward negative. How to decide whether to use sigma m0 or sigma y0? Judiciously you have to judge which equation is better so that other unknowns will not come into picture. Now you see, after cutting it, I told you I don't want to draw the arrow marks, separate free body diagram. After cutting it, I will free body diagram of RHS of 1 1 when you take it. We don't know whether the members are compressed or pulled. So force in the member BC, DE, some arrow you assume, because you don't want to deal with that anyhow. And CE member, correct arrow mark, you can fix it. Cut here, look right side. See, these 2 horizontal forces will not have vertical component. So they don't come into picture if you write sigma y0. So if this is upward force, to balance this upward force, it has to be downward only. So the question of negative sign also will not be there. So like that we will fix the correct direction for this one. These 2, any direction you put it, it will not matter at all. Because of this reason, you see, cut here right side when you take it, this portion of RHS of 1 1 is in equilibrium under the action of BC, CE, DE 5. That's all. Cut like this, throw this piece out, only this must be in equilibrium in its isolation. Its separateness, it should be in equilibrium. So when I write sigma y0, 5 kilonewton upward, so plus 5. FCE downward, but not vertically downward, it is inclinedly downward. What's the y component of that sigma y when you are writing? FCE sin 45, you will get y component. So minus FCE sin 45 must be 0. So FCE will get 5 by sin 45. You will get 5 root 2 kilonewton. See, the question of negative sign will not come because you have already taken care of that. Because the arrow here upward, it has to be downward. So 5 root 2 kilonewton, correct arrow mark we have taken, so tension. So one of the options will be this one, 5 root 2 kilonewton tension. So in 2 minutes time in the exam, your task is only these two lines. So you can complete in 30 seconds maximum. First take the reactions, cut it, RHS, on the question itself you can show the arrows. Correct arrow mark we can take it either sigma x or sigma y. One equilibrium equation only we have to use in the exam. Okay. So this is about the method of sections. Now let us see one more question. Now let us see one more question. Force in the member AB. This let us say AB, C, D, E. Assume that there is a load of 20 kilonewton, 3 meters, 3 meters. Okay, this height is also, let us assume that 3 meters. This type of trusses, if the two supports are in at one side, other side it is free to deflect downwards, say. Such trusses we call them as cantilever truss. Similar to a cantilever beam, you can have a cantilever truss. Okay. Now, if it is the case, earlier problem we have cut it to the right side. It is not necessary that we should always cut right side and cut it right side inclined and right side portion. We should take our choice. Whatever way you want, you can cut it, but ensure that don't cut more than 3 members. Cut members should not meet at one point. Truss must be divided into two separate parts. Otherwise, what happens? Only 2 members you cut and equilibrium say. When you separate it, since you didn't cut it, that also will come with you. Once you cut it, means one portion you should be able to throw it out. To that extent, we should cut it. Earlier problem we have cut like this. Now we will cut this way. So this is how you have to make it. FAB you want. Cut it by 1, 1. Now we will consider equilibrium of RHS, LHS of 1, 1. Why not RHS of 1, 1 we should take? If I take RHS of 1, 1, here 2 reactions, here 2 reactions, 4 reactions you have to find. Then those movements you have to see. Unnecessary headache. But if I take left side, I have to deal with only 3 member forces, no reaction we have to find. So after cutting, you have to see which side is better for us to get out of the problem quickly. So that's why we have taken LHS of 1, 1. Cut here, throw this piece out, only LHS. These arrows, whatever way you want, you can put it. Force in the member CD, force in the member AD. How you keep these two arrows, it doesn't matter at all. But AB will put it correct arrow mark. Now you see, in this case, The unwanted members means the members which we don't want to find forces, those are meeting at D. If I take moments of all force about D, these unwanted forces will give 0 moment. Our headache is gone. So, they will not come in the equation at all. So, that is why now we will take summation of moments of all force about D equated to 0. This is the sign convention, clockwise positive, anti-clockwise negative. It is not a bending moment equation, it is equilibrium equation where you do not deal with any bending moment, only moments. What is the difference? If we simply say moment of a force means engineering mechanics, the external effect of a moment only you are considering, internal effect of a moment you are not considering. External rotational effect of a force is called moment, whose internal effect can be bending or twisting, depending on whether it is bending the member or twisting the member. We are not considering any internal effects. Internal effects you consider in strength of materials. External effects you consider in engineering mechanics. Such external effects only we are dealing. So, no bending here. Sagging bending moment, hogging bending moment, we are not dealing at all. So, first take 20, tail to the head towards D, anti-clockwise. So, minus 20 into 3. Now, you see, this is giving negative moment, tail to the head towards D is anti-clockwise. To balance an anti-clockwise movement, it should be clockwise movement. So, your arrow must be like this, FAB. See, tail to the head towards D, clockwise. We should not put arrow mark like this, FAB. Tail to the head towards D, again clockwise only, but there is no member here to give that force. You must draw the arrow mark in the direction of the member only, so that if you travel from tail to the head of a force and towards the point, it should give you clockwise rotation, because already this is giving anti-clockwise rotation, anti-clockwise movement. So, plus FAB into 3 must be equal to 0. So, you will get FAB 20 kilonewton directly. Now, you see arrow mark is away from the joint, so tension. Again, you see only 2 lines must be there. In the exam, we do not have to explain to anyone which equilibrium of you are taking, RHS or LHS. How you are cutting, we do not have to explain. Only this must be there in your rough work. In 30 seconds, you must close it. Okay. So, this is the scope. Which member? Method of sections means that cut the member, RHS or LHS you take equilibrium, use only one equilibrium equation, sigma x0, sigma y0 or sigma m0, only one you have to use it, because by the time you use one equation itself it will be sufficient. If you have to use 2 equations of equilibrium or 3 means it will become a 20 marks question. Okay. So, scope only is up to here. Done. Now, we will take the continuation of the method of sections problem. Last class I told you how we have to cut the section. You must cut the members such that don't cut more than 3 members. All the cut members should not meet at one point, and cut the members such that entire truss is divided into 2 separate parts. Then we can take a particular free body diagram, either left hand side of 1 or right hand side of the cut section. Whatever side we want, we can take it, and that part should be in equilibrium in its isolation. So, from that, because method of sections means 3 members are not concurrent, we have 3 equations of equilibrium, sigma x, sigma y, sigma m. If the 3 members are concurrent, then sigma m becomes useless. Then it becomes method of joints problem. So, if you are able to use sigma m is equal to 0 also after cutting the members, then it means it is a method of sections. If sigma m is equal to 0, you get 0 is equal to 0, then automatically that method becomes method of joints problem. So, like that I have given you the introduction to method of joints, method of sections. Now, continuation of the problems we will take it. Force in the member AB. Assume that we have a truss like this. This member you take it as say A, B, then the others you can take C, D, E, F, G, H, whatever we want. Assume that there is a load of say 20 kilonewton. Here also there is a load of 20 kilonewton. So this is 2 meters, let us say 4 meters, 2 meters, 4 meters. So now we have a truss like this. It is a simply supported truss. If at all the two supports are on one side and one end is free to deflect downwards, then I told you it is a cantilever truss. Now it is a simply supported truss. Behaves like a simply supported beam. Okay. Now the first step is to find the support reactions. So first step to find support reactions. Now in this case, when you are finding the support reactions for simply supported beam cases, whether the structure is symmetrical or not, if the loading is symmetrical, supports will share the load equally. Now you will get say VC is equal to 20 kilonewton, then VE is equal to 20 kilonewton. Assume that it takes around 5 seconds time to detect what are the support reactions. Now we want to find force in the member AB. In another 10 seconds time, your task is that cut the member AB by a section 1-1. You can take equilibrium of either LHS of 1-1 or RHS of 1-1. So this is the process. Cut AB by 1-1. You take equilibrium of LHS of 1-1. Don't want, we can take RHS of 1-1 also, our choice. Whichever side is easier, that side we will take it. Now if I take RHS of 1-1, I told you we have to keep the arrows on LHS of 1-1 only. So keep arrow marks on LHS of 1-1 only. So that we will keep the arrows separate free body diagram of LHS of 1-1 we don't want to write. It will simply waste our time. What extra is there when you write LHS of 1-1 is that entire free body diagram 3 arrows. Those 3 arrows we can show here itself. AB member we will put later. First, we don't want GB member, AD member. How you put arrow marks, it doesn't matter at all. So FBG, FAD. Because they will not come into equation at all. Now we want to put correct arrow mark for force in the member AB. Cut it, look left side. Then, because these two members are horizontal members, forces are horizontal, we don't want them in our expressions. Equations, we don't want them to appear. So, for them not to be seen in the equation, if I write sigma y0, let us say, this acting horizontal, horizontal. Now, whose y component is 0. So, these two will not come into picture at all if I write sigma y0. Now, this arrow mark, if you want to fix it, now you see here, stand here, look left side. What's the net force? 20 up, 20 down. So, this we will not see, only external forces we have to see. So, 20 up, 20 down means net force is 0. So, that means force in the AB also has to be 0. Then, how you put direction for FAB also it doesn't matter. It has to be 0 only because of this reason, 45 degrees. Now, you see, if I write sigma y is equal to 0, upward force is positive, downward force is negative. So, 20 upward, so plus 20. Next 20 downward, so minus 20. In the process of writing the sigma y0, it is an external equilibrium equation. Internal forces we should not show. External forces means on the free body diagram, as I told you already what is a free body diagram. It is the diagram of a body on which what others are doing you have to show. So those other member forces what they are we have to see, only there you have to write. 20 is your LHS of 1-1 means this is your free body diagram. On this free body, 20 up, 20 down, FAD, FAB, FBG is acting. These forces we should not show because they are uncut members. If I show towards joint, here also towards joint I have to show. 2 arrows are there, so they balance themselves. So it utter waste of time to show arrow marks here and here, here and here, here and here. So uncut members, no arrows must be shown, because that is the within the free body diagram. What happens is those forces get balanced. So we should not show them, but these you have to show. LHS of 1 1 is in equilibrium under the action of 20, 20, FAD, FAB, FBZ. That's all. Only these 5 forces must come. So 20 up, 20 down. Next, FAB sine 45. The Y component of FAB is FAB sine 45. Sine 45 can't be 0. That means FAB has to be 0. In 2 minutes time, our task is only this much. How you cut, whether you consider LHS or RHS, you don't have to explain to anyone. But this equation you will have to write. But even this also time wasting. We cannot write in the exam cutting it so much, plus 20, minus 20, FAB sin 45 also is a waste of time. By inspection itself, how we have to calculate. Let us see, this is what you have studied in strength of materials. See here, if you have a simply supported beam, central load W is there, let us say, this point let us say A, B. Now VB is W by 2, VA is also W by 2. Now shear force at XX, if you want to find this section XX, let us say, what is the shear force at XX? This is the process you have done. Stand there, look one side. Section right side upward. W by 2, it is a negative shear force. That shear force, because you are finding it in a beam, it is called beam shear. Beam shear means shear force in a beam. Shear force at XX is called beam shear. Now, when you come to this problem, just you see process is this one. Stand there, look one side. Section right side upward, W by 2. You got it. Now, let us come to this one. Same way if I stand here, this section XX, let us call it. Now, shear force at XX, is called panel shear or panel shear force. Okay. Now, panel shear force means similar to the beam shear, stand there, look one side, stand there, look one side. So, stand here, look one side, section right side upward, you got 20. Now, that shear force, we don't call it as beam shear because you didn't calculate in a beam. In a panel of a truss, you calculated. This is first panel, second panel, third panel, like that we read. So, since you are calculating now shear force in a panel, we call it as panel shear force. Then that is beam shear, panel shear force. In a 2-hinged or 3-hinged arches, which we will study again later, in radial direction you calculate shear force. There also that shear force you call it as not beam shear or panel shear, you call it as radial shear force because you calculated shear force in the radial direction. That extra word you are putting, shear in a beam is beam shear, shear in a panel, panel shear, shear in an arch, radially you've calculated. So you add one more word, radial shear force in the arch, because you are calculating in the radial direction in the arch. So now see here, if at all that panel shear force is 0 in any panel, force in the inclined member in that panel has to be 0. Because panel shear force is there now, stand here, look right side upward is 20. This 20 kilonewton load should be balanced by this member only. That panel shear force in a truss is balanced by the inclined members only. Now this inclined member is not subjected to shear force. The axial force in this member has a vertical component. that vertical component will resist the panel shear. Such analysis we have done in RCC also. RCC, if you take the beams, shear force in a beam at any section when you are calculating at the support, then bars are bent up bars are there. You calculated shear force resistance by a bent up bar. So whatever shear force is there in the beam at the critical section, shear force V, and that is resisted by bent up bars. But that does not mean that bent up bars is subjected to shear force. Bent up bars in RCC beam are under tension, whose Y component of the bent up bar tensile force will resist the concrete shear. That's what you have learned in RCC. So that also comes from this analysis only. The vertical component of this diagonal member will resist the panel shear, and so this member now will be under tension or compression. Now if you stand here, look right side, this is upward force. To balance this, it has to be downward. That means this member is under tension, so it won't be 0. Now come to second panel, stand here, look right side, 20 up, 20 down, net panel shear force is 0. If panel shear force is 0, force in the inclined member in that panel has to be 0. Just stand there, look one side. If this force is 0, say unbalanced vertical force, then it has to be 0. This much we cannot do and say that force in the member is 0. Just by inspection, find the reactions. This is valid only when the reactions are symmetrical, forces are symmetrical, reactions are same. Then in this case, the panel shear force at 1 will be 0. If it is 30 kilonewton, this is 20, say, supposing that applied loads are not same. Then what happens if you stand here, look one side, this is 30, this is some 20 only, let us assume, or 25 like that. Then 5 kilonewton force will be there. Only when the panel shear force is 0, then force in the inclined member in that panel will be 0. If at all two members are there, then individually forces will not be 0. Sum of the y components of those two diagonal members will be 0. Individually they will not be 0. In a determinate structure, in a panel, only one diagonal member will be there. So we can say that it is 0. If you have indeterminate structure, one more diagonal is there, say, then sum of the vertical components of the two diagonal forces will be 0. Sum will be 0, individual forces will not be 0. Okay. Now you see, this is what we have learnt. Conclusion. If panel shear force in any panel is 0, force in the inclined member, force in the inclined member in that panel is always 0. Now we found three ways of finding 0 forces just by inspection. What are they? At a joint, if two members are meeting, two non-collinear members are meeting with no external load at the joint, then forces in both members are 0. If three members are meeting, two members are in line with each other, collinear, force in the third member will be 0. Third one is, if panel shear force in any panel is 0, force in the inclined member in that panel has to be 0. With this understanding, in the exam, you will have a 2 marks questions. You have 1.5 minute time, but you can complete in 30 seconds time. So all the three methods you should be able to apply in the exam. Now, when it comes to this one, we call it as panel shear force. Why we call it as panel shear force? Why the beam and the truss we are equating? Actually, the truss action comes from the beam action only. A beam action is converted into truss action. How it is converted is like this. Note 2. Beam action converted into truss action. That means how the trusses are evolved. We want to see now. Assume that we have a beam like this. Subjected to some loading. Now, due to this load, the deflected shape of the beam is something like this. This is what you have learned in strength of materials. Okay, that's the deflected shape of the beam. As you have studied in SM, bending stress distribution at the neutral axis level is 0. This one is actually a solid rectangular section. So heavy weight it will have. At the neutral axis level, bending stress is 0. That's what we have learned. So when bending stress is 0 at the neutral axis level, why should we have a solid rectangular section throughout the length and waste our money? So people thought, instead of having metal here, you remove that metal completely. Now you will make it as like this. What we do is, they have cut a small slice here. Take scissors and make a small slice like this. So a small strip you will get. Again cut them into pieces. Connect them by links like this. So cut it, again cut them. Those small pieces, connect them by links. Here also take scissors, cut it, take a small slice. And that slice also you connect it with the help of pins. Like this. Now entire metal you have removed. If you remove the metal completely, this will become unstable. So to make a mechanism like it becomes, so connect them like this. Like this. But still it is unstable. As I told you in the beginning of the class, that link mechanism will be stable only when it takes up a triangulated form. If links form like a square, easily you can slide them. Without force also it can come like this. That means a rigid body translation, rigid body rotation we can make it. So it behaves like a mechanism. So to prevent that rigid body translation and rotation, you add diagonal members also for each uh, square section. Like this you form it. Now you see. Now you cannot, if I slide like this, these members will be under tension. Without elongating those diagonals, you cannot slide them. That means horizontal forces, vertical forces, this mechanism can effectively resist. Such link mechanism, we call it as a truss. So, this one is everywhere holes only. There is simply supported beam, sir might have told you, maybe depth of the beam around 600 mm, that means 60 centimeters. Earlier problems we have written 4 meters, that means one floor height you can have. That means weight also very less because everywhere only wires like construction is there, everywhere holes only. Weight is minimized. So, a beam which can resist the bending moments etc. for a span of 5 meters, let us say, these can resist up to 30 meters also. You can go for more spans without any intermediate columns because weight is less, height is more. So, your bending compression, whatever you are getting, the top layer is subjected to bending compression. Whatever bending compressive stress is there is resisted by top chord members only. In a 4 meters depth, this will be a thin layer type thing will be there. Maybe 300 depth may be there, but in a 4 meters depth, this acts like a line. So compression will be there in that. So bending compression is resisted by this one. Bottom fibers here are under tension. That's what you have learned in SM. So all bending tensile stress is resisted by bottom chord members only. Now you see beam shear is there, W by 2. That shear force in the beam now will be resisted by panel. This diagonal member, vertical member will resist the beam shear force in the form of panel shear. So Instead of calling panel shear, we call it as a beam shear. Instead of calling it as a beam shear, now we call it as a panel shear. Now, whatever force is there, vertical force, there also shear force is there. Shear force is W by 2, and the entire rectangular cross section has to resist that W by 2 load. Waste of money, shear force and shear stresses. If you see strength of materials notebook, the shear stress value is around 15 Newton per mm square, like that will be there. But its capacity is 250 by root 3, like that. So much underutilized cross section. So where you have single wire or single rod can resist the shear, why should we have entire rectangular cross section and waste our money? So panel shear is resisted by the diagonal members. Length may be say 4 meters or 5 meters, whose cross section will be very small compared to the length. So axial force will be there, whose y component will resist the panel shear. So this is what happened. Now this is a truss section. Beam is converted into truss. In the process, wherever top fiber you call it as bending stress, now we call it as axial stress. We don't call them as bending stress because you have connected small pieces. Each small piece is subjected to axial force only. That's why length should not be too much. They will bend. Bending behavior again will come like that. So small components, though compression like that will be there. Okay. So this is what happened. Bending compressive stress is resisted by top chord members as axial compressive stress. So it is transferred as axial compressive stress. Then bending tensile stress is resisted by bottom chord members as axial tensile stress. Then shear force in the beam is resisted by vertical and diagonal members. Vertical and diagonal members in a truss. Like that. So entire beam, whatever bending, tension, bending, compression, shear force in a beam are there, they will be resisted by separate components. Top chord members, bending, compression, bottom bending, tension, shear force, diagonal members and vertical members. So in the process, we have formulated them like a triangles. So because triangulated pin jointed structure is more stable. If links form like triangles, they are stable structures, can take horizontal, vertical loads in plane loads. Okay, that's why I told you in the class, earlier class, that in a truss, all members are called links only. Link means a straight member connected by pins at the ends, so that they will only take axial force. No bending moment is possible on these members as long as you apply loads only at the joints. If you apply load at the intermediate location between the joints, then the member will bend. We cannot call it as stress, and stress analysis you cannot do. Okay. So with this understanding, now let us see how to find members having zero force. 1 minute. Just break. Now we want to see members having zero force, how to find. Members having zero force are. Is a 2 marks question. You will have say 1 minute time. This point say A, B. Let us say here 30 kilonewton, C, D. This is also let us say 30 kilonewton, E, F, G, H, I, J. Distances they have to give us to know whether the frame is symmetrical or not. This is say 3 meters, 3 meters. Let us assume that this is 4 meters, like this. Loading is symmetrical, truss is also now symmetrical. Okay. Now, if you see to find members having zero force, observe that in this case loads are same. If the loads are different, some of the forces may not be zero. Okay. Only when symmetrical case, when forces are same, we are taking. In one of the civil services, they didn't give the loads. So, we will not be able to tell whether they are which members have zero force or not. Such cases, you will take members, the forces don't take them equal, general forces you take, one is 30, one is 40. If they don't give you the magnitude, you take them are different, they need not be same. Then accordingly you fix it and select one of the answers. It's like that. But if loading is given, no issue at all, we will know from this one. Now you see, because the reactions are uh, loading is symmetrical, support reactions are same. So VA is 30, VE is also 30. Now I told you to find members having zero force, first way of checking is this one. At a joint, if two non-collinear members are meeting with no external load, forces in both members are zero. Now come to this one. Joint F, let us say first. Two members are there, GF, FE, 1, 2. No external load here. Maybe external load here or here, we are not interested. At this joint, two members are there, no external load at this joint. Then both members will have to be 0. So, one concept we have used here. Same thing, take J, JI, JA. Two members are meeting at J with no external load, which means that force in both members are 0. Next, take C here, 1, 2, 3. 2 are in line, third must be 0 because no external load here. Maybe load there or not, we are not worried. Load is not there here, that is enough. So, second method we have used. Now, third method is panel shear force. So, panel shear force. First panel, what is the panel shear? Stand there, look one side. Section right side here now upward is 30. So, panel shear force is 30. So, it won't be 0. Stand at the second panel. What is the panel shear force? Stand here, look right side. 30 up, 30 down. Net is 0. So, force in the inclined member has to be 0. Next, come to third panel. Stand here, look right side. 30 down, 30 up. They balanced already. So, panel shear force is 0. Force in the inclined member is 0. Stand here now, look right side. Now, 30 extra is there. So, it won't be 0. That's all. So, you see, for each panel, if you draw free body diagram, then cut the beam, look right side or left side. So, force in the member G is not 0, G is 0, like that. We cannot manage in the exam. That is for the beginners. Cutting there and see how it looks like. After understanding that, this is how you have to stand. Stand here, look one side, over. 0 or not, you detect. Stand here, The sum is 0, so it has to be 0. Like that. First, you are expected to know those concepts beforehand. So in the exam, that's why it is a 2 marks question. You have say 1 minute time we can complete. 1 minute you can use it for some other problems. Okay. So how many members are there? Sometimes they ask you number of members which have 0 force. Sometimes they ask you what they are. So number of members having 0 force is equal to 7. What are they? AJ, JI, BH, CH, DH, then FG, EF. Now you see force in the member BH, force in the member DH, 0 because panel shear force is 0 in second and third panels. This is for our understanding. Why they are 0 in the later stages, you will know. That means when you are revising it, quickly you can get it. Or if when you are seeing previous GATE books, etc., you will know quickly. Now, if you see the GATE previous books or prelims books, you will know how quickly by inspection itself you will be able to solve the problems. Okay, this is the members having 0 force. Now, let us see one more question. Force in the member AB. See here, this is the truss now. It's like a cantilever truss because two supports are one side. Assume that there is a load of 40 kilonewton. This point, let us say A, B, C, D, E. A, B, C, D, E, F, you can take it here. Now, other panels you can name otherwise G, H, I, J, K, L, like that. So, this span, let us say 4 meters. This span, let us say 2 meters, 2 meters, 2 meters. Okay. Now, we want to find force in the member AB. We want to use method of sections because it is intermediate member. Any intermediate member, if you are asked to find force, first you must try method of sections only. Can we complete in 20 or 30 seconds time or not? First you have to observe. If that is not possible, only we will go for the other ways of finding that. Now you see AB member is an intermediate member. If I cut horizontally, 1, 2, 3, 4 members are cut. I told you that preferably means as far as possible, don't cut more than 3 members because we have only 3 equations of equilibrium. Once you cut 4 members means 4 arrows you have to write, that means 4 unknowns. 3 equations of equilibrium you cannot manage. So let us not cut that way. Supposing that if I cut like this way, then 1, 2, 3, 4 are cut. So we'll remove that. Giant B equation method of giants, if I take it 1, 2, 3, 4 here, 1, 2, 3, 4. Whatever way you cut it, method of joints you take it, method of sections you take it, minimum 4 members are getting cut. Such cases where minimum 4 are getting cut, then you have to cut 4 members only. But ensure that you are cutting the members such that the all unwanted members that you don't want to find are meeting at one point. What's the advantage of that? Those all unwanted members, if they meet at one point, if you take moments of all forces about that point, then all the members will give 0 moment except your wanted force. That way even 10 members are meeting at one point, say. 11th member is not meeting at that point, you want to find 11th member. Okay, 10 members movement about that point, you will take it, they will give 0 movement. Headache is gone. Finally, we want to get out of the problem in 30 seconds time. All unwanted members, if they meet at one point, okay, all headache is gone at once. So that's why in this case, minimum 4 are getting cut. So you decide to cut, say like this. Cut it by 1 1. It is not necessary that your cut section must be horizontal. It can be inclined like this. Any which way you want to cut, you can, if you want, you can cut it. What is the advantage of cutting it like this? See how many members are cut? AB, BC, CD, DE. 1, 2, 3, 4 members are cut. Out of that, 3 unwanted members are meeting at D. You see, line of action of the force BC, if you extend it, it passes through D. ED passes through D. CD passes through D. So our headache is gone. If I take moments of all force about D, these 3 members will give 0 moment about D. Then only unknown is AB. We can find easily. Also, second point, it is not necessary that you have to take LHS of 1 1 or RHS of 1 1. You can take upper side of 1 1, lower side of 1 1. Just cut it. One section you have to take it. Only care that you have to take is all the cut members should not meet at one point. If they meet, it becomes method of joints problem. So now you see how you keep the arrow marks for BC, CD, D. It doesn't matter at all because they give 0 moment about D. FBC, FCD, FDE. So these 3 will give 0 moment about D. So no headache. But AB will put correct arrow mark. Now you see, cut, this is the process. Cut AB by 1 1. You will consider equilibrium of upper side of 1 1. If you take upper side of 1 1, so keep arrow marks on upper side of 1 1 only. Okay, because that is the one you are considering. Lower side of 1 1, why we don't keep arrow marks? Cut like this, take it, throw it into dustbin. In the dustbin again you don't want to manage anything. So throw it out. So you don't have to keep arrow mark and throw it out. So this is with you. That part you are dealing, so keep arrow marks there only. Now you see these things, if after cutting it upper side of 1 1, these unwanted members are meeting at D, so they give 0 moment about D. Now you see, this 40 kilonewton upper side of 1 1 travel from tail to the head towards D. It gives a clockwise movement. If this is giving clockwise movement, FAB should give anti-clockwise movement. Otherwise, sigma m will not be 0. So, FAB arrow mark, you have to keep it like this. Whether you write FAB or FABA, it doesn't matter at all. Force in the member AB or force in the member BA. Same. Now, you see, travel from tail to the head towards D, anti-clockwise. So, no question of negative sign. So, upper side of 1 1. So, we are taking moments of all force about D is equal to 0. Clockwise positive, anti-clockwise negative. See, this is an equilibrium equation, not bending moment equation. It is an equilibrium equation, not bending moment equation. What is the difference? Equilibrium equation means it deals with external forces and external effects only. Equilibrium equation, it deals with external effects of forces only. External effect of a force is what? External rotational effect of a force is moment. Only that moment you will write here. Whether this moment is bending the member, twisting the member, you don't want to worry in this sigma m0. But what is bending moment? Then here you are worrying whether that moment is bending the member or twisting the member. So, bend moment equation means this bend moment equation, it deals with internal effects of moments, whether that moment is sagging the member or hogging the member. It is a deformation equation. How it deforms, based on that you will fix the bending moment, positive or negative. Because of the moment, if a member sags, you take positive. If a member hogs, you take it as negative. So, based on how the member is deforming, you fix the sign convention. That's why bending moment sign conventions, we also call them as deformation sign conventions, whereas this is equilibrium sign convention. No deform, whether it is sags or hogs, we will not worry. Whether if there is a clockwise movement, there should be anti-clockwise movement of same magnitude, otherwise it will keep rotating. That effect only we will see in the equilibrium equation. Now you see, first you take these member forces, you should not draw, because this is our free body diagram. Within that body what happens we should not show. On that body what others are doing you have to show. FAB, BC, CD, DE, these forces are exerted by the lower side of 1, this member, this member, this member, and this member, this member, this member. What these members are doing on the upper side of 1 you have shown. That is called free body diagram. And these arrows are the forces acting on the joints. Who will exert? This member will exert on this member and pull them. So that's what we have done here. Then travel from tail to the head towards D. 40 into 4 plus 40 into 4 minus, you see, travel from tail to the head towards D, anti-clockwise. So, minus FAB into 4 should be 0. So, you will get FAB is equal to 40 kilonewton. Arrow mark is away from the joint, so you have to write tension. Okay. So, one of the options is 40 kilonewton compression, 40 tension, like that they ask. 40 kilonewton compression should be able to answer. So, in the exam in 2 minutes time, your task is how you have to cut. Whenever you see this type of triangles, whatever you are cutting, 4 members are getting cut, say, check this one, whether it can manage or not. Okay, cut it, show the arrows, then do this one. This you don't have to tell, I am dealing with external effects, kindly see that, or I am dealing with internal effects, you don't have to explain. It is for our understanding what's the difference. In first year engineering mechanics, you have dealt with external effects of the forces. Second year in strength of materials, the internal effects of those forces you have seen. What are the internal effects? Tension, compression, bending and twisting. Those effects you have studied in strength of materials here. That is the bending moment. Okay. Now, this is how you have to calculate. Supposing that when you are cutting the members, all unwanted members are not meeting at one point, say, minimum 4 are getting cut and unwanted are not meeting at one point. Then take some other help to finish off in 30 seconds time. Let us see how we should solve them. Okay, now let us see one more problem. Force in the member AB. So, this joint, let us say A, B, C, D, E, this point F, say G. Here you are applying a load of say 20 kilonewton. This angle of inclination 30 degrees, 30 degrees, 30 degrees, like this 30 degrees. This is also 30 degrees. Okay. Lengths are also not given. Now, first task is to find the support reactions. Since 30, 30 everything was given, this is also 30 degrees. Structure, loading are symmetrical. So, Vg you will get 10 kilonewton. Now, when you want to find force in member AB, you can use method of joints or method of sections, let us say. Out of this all entire truss, which joint has only two members, so that method of joints we can use and break it. See, you will find that in this truss, all the joints have a minimum of 3 members. So, method of joints directly we cannot take it sigma x 0, sigma y 0 without understanding, we cannot make that. Next, method of sections. If you cut vertically, 1, 2, 3, 4 are cut. Okay, no problem, 4 are cutting, but if these 3 members are meeting at one point, we can manage. But these 2 members are meeting here, these 2 members are meeting here. So, we cannot manage. So, 3 are not meeting at one point. So, method of sections also we cannot use. We can use it, but 2 sections we have to take it, simultaneous equations we have to solve. It will take say half an hour time. So, but we have only 1 minute time. So, method of joints we tried, 3 members, all joints have a minimum of 3 members, we neglected. Whenever way, whatever way you cut it, 1, 2, 3, 4, if you cut it here, 1, 2, 3, 4, and all unwanted members are not meeting at one point. So, method of sections we do not want to use. Such cases, you have to see the overall configuration of the structure to get out of the problem quickly. Structure is symmetrical, loading is symmetrical, which means that member forces also must be symmetrical. That is what you have studied in strength of materials. You have a simply supported beam subjected to central point load, say. Two reactions are same, shear force same, bend moment symmetrical, everything is mirror reflection. Deflection profile also you get the symmetrical profile. So, member forces also will be symmetrical. From that understanding, you will find that force in the member FD, force in the member FA must be same. Otherwise, the symmetry will not be maintained. FFD, FFA must be equal. Now, whether they are tension or compression. Now, see at the joint F, you hold it and pull it down. How these two members should respond? They should pull it up like this, otherwise it will fall down. So, this member it has to pull it up to balance this one. So, force in the member FD, force in the member FA. like this. Okay. Now, these arrows also should not be kept wrong way. You can keep it by inspections. I pull it down, they will push it up, pull it up like this. So, correct arrow marks, we have kept it. Now, these two members we don't want to know. Now, I can write sigma y0 because FFD is nothing but FFA only because of symmetry. They have to be equal. So, from that symmetry, we can break FFA. Once FFA is known to you, here at free body diagram of joint A, I can take FAB, I can find. So, this is the process. Okay. So, this is first point. Your solution, first point is from free body diagram of joint F. This much is enough. Again, same thing, we don't have to write in the rough work and waste the time. It's visible here. You write now sigma y is equal to 0. Upward force is positive, downward force is negative. So, plus FFA sin 30 plus FFD sin 30 minus 20 must be 0. Then these two members will not come into picture because they are horizontal, y component is 0. Then this FFD is nothing but FFA. Why? Because of symmetry. So, 2 FFA sin 30 must be 20. Sin 30 is half. So, FFA is 20. Now, see the arrow mark away from the joint. So, that means it is tensile. You are writing tensile because of the arrow mark. Not because of the tensile you have kept the arrow mark. First arrow you keep it. Now see whether it is arrow mark is away from the joint or towards the joint, then decide whether it is tension or compression. Okay. Now FFA is 20. Here also away from the joint means far end also same 20. 30 degrees. This angle is also 30 degrees. Now if I take this is now first point. Now second point is from free body diagram of joint A. Joint A. From the joint A, which equation of equilibrium is better to get out quickly? See, I am not interested in the force in the member AG because they asked only AB. So, to eliminate this one, I can use sigma x0. If I write sigma y0, this will come. Then method of joints, 3 members are meeting. Still, one member is known to us. So, only this we have to find. So, we will use sigma x0. This arrow mark is going down to the right. If arrow mark is going down to the right side, the balancing one must act left side like this. So, this FAB. Now, you see this angle 30, this angle 30. That means forces must be same. Why they should be same? This is 20 cos 30, right side. This is FAB cos 30, left side. Cos 30 cancels, 20 will remain. So, FAB must be 20. Supposing that you didn't understand what we talked, let us say. First of all, by inspection you have to find it. Next problems onwards, by inspection only we will write. No question of writing sigma x0, sigma y0 and wasting the time. In this case, now you see, you will write now sigma x is equal to 0. Any force that is acting right side positive, any force that is acting left side negative. So, plus 20 cos 30 minus FAB cos 30 is equal to 0. Cos 30 cancels out. FAB will become 20. Arrow mark is towards the joint, so compression. So, in 2 minutes time, our task is to observe, can we use method of sections or not? Method of joints, if I have to use, which one joint is better? Then, having understood that point, joint F first we have to take it. Because of symmetry, they have to be same, and FFA we have to find. Once FFA is known to us, FAB By inspection you can find this not required. In 2 minutes time you must do this much. This is the scope for the GATE exam or prelims exam, whatever exam you take it, this is the process. This much time only you have to spend. Anything extra, big equation you are writing, say, immediately stop that. That is not the way to solve the problem. Check where we can simplify. They have to give us the questions such that it will take only 30 seconds time. So all 20, 25 years papers if you see, they don't take more than 25 seconds time. Okay? Because that is the scope of the exam. They don't want you to calculate too much, to think too much. Have you understood the basics of the subjects or not? That is the aim of the any exam. Okay? Now, to further increase the speed of our uh, solving capabilities, we should know about a principle called principle of transmissibility. Principle of transmissibility. This first year in first year engineering mechanics, we have learnt about this principle of transmissibility. What it tells you is, supposing that we have a block like this, you are applying a force P this way, acting at A. The external effect of a force P on a body remains the same when it is replaced anywhere along its line of action. That means, on this body at A, if you apply this force P, say, then it will be pushed up. That is effect. Now, effect will not be changed if you apply here also. This is the B, say. Apply same, pluck it, keep it here and pull it, simply same external effect is same. Don't want here, I can put it here also at C. The effect of this force on this body again same. External effect only. External effect means you must see, come outside the body and observe what is the effect of that force on the body. It will be pushed. At C also effect is same because this is the body, here force, then it's air. You must imagine that you have attached a wire like thing and hold that wire, pull it, then effect is same. That is the principle of transmissibility. The external effect of a force remains the same when it is replaced anywhere along its line of action. So, it states the external effect of a force remains same when it is replaced anywhere along its line of action. But internal effect may be different. Now, what is the difference between external effect of a force and internal effect of a force? External effects you have studied in first year, internal effects you have studied in second year under the chapter strength of materials. External effects first let us deal. Assume that I am standing on a road playing with the cell phone, and you are observing standing on a footpath. You saw me and observed that I was playing with a phone. You also were doing chit chatting. And two buses in opposite direction they are coming, let us say. One of you have a calculator thing, and you measured that the acceleration with which bus is moving, other direction bus is moving, with what acceleration, mass of the body calculated. So the resultant force acting on the bus you calculated. You found that net force was a 10 ton. One bus is a net resultant force is 10 ton, another bus is also 10 ton force. I am standing here, you calculated both buses are coming 10 ton this way, 10 ton this way. You thought that I would be in equilibrium. So 10 ton this side, 10 ton this side means sigma x 0 happened. So sigma x 0 means I am in equilibrium. So as far as you are concerned, I am in equilibrium. I am at rest. So you thought that Swami Gupta will be in equilibrium and you managed yourselves. Then when I am standing here, when two buses hit me, I will be in equilibrium only. External effect is nil. But internally I will become like a paper. One 10 ton and another 10 means I will die. The pain of that force I only will feel. The internal effect I only will feel. That is the difference between external effect, internal effect. Come outside me and you observe that I am in equilibrium. That is called external effect. Internal effect is felt by the body. Then if it cannot take that, it will get crushed. And that is compression, we call it. If I cannot take it, I will die. If I can take it, I will withstand those stresses. Okay, applied forces in the form of stresses, I will resist them. If I cannot resist, I will die. So internal effects are that. So much difference is there between external effect, internal effect. Such external effect remains the same, but internal effects may be different. And mathematically, if you see, now you have full idea about external effect, internal effect. External effect as seen from outside the body, internal effect as seen within the body. Supposing that we have a member like this, say, you are applying two forces, P here, another P here. Come outside the body, as far as you are concerned, it is in equilibrium. That is called external effect. External effect is it is in equilibrium. Internal effect, if you cut here somewhere, then what this body will do on this one is called what? Strength of materials you have studied, internal resistance offered by the material, offered by the cross section. This will exert on this one at this level a force P. That resistance is called internal resistance. That force exerted by in the free body diagram, whatever force you show, which is exerted by the other body on this body, that is called internal resistance. If the member has capacity to take that much force, it will remain. Otherwise, the member will break. So internal effect is what within the body it will sense a tension, because any member is subjected to two pulls, it is subjected to tension. It is in equilibrium, so no force will develop, not possible. It is in equilibrium, but internally it is subjected to tension. If it cannot take that much tension, it will break, though it is in equilibrium. It should have the capacity to take the load. If it cannot take, means equilibrium will be lost and it will break. Now, if principle of transmissibility, what it tells you is, such members which are in equilibrium, you can replace the force wherever you want. This member force, I can pluck it, keep it here, like this. Okay. This member force, this I pluck it, keep it here, like this. Now you see, this I kept it, this I kept it. Now come outside the body and see, it is still in equilibrium. But internally, see, it is under compression. This is the meaning of that. Principle of transmissibility tells you that external effect remains the same but internal effect may be different if you replace the force anywhere along its line of action. Now two forces we have replaced. This you keep there, that you keep it here, keep it here, keep it here. Still effect is same. External effect is same. Okay. Now but internal effect may be different. This concept we will use it when you are finding the forces in the members, not to detect whether it is tension or compression or sagging movement or hawing movement. We cannot find from the principle of transmissibility which how much force is there in a member, whether it is tension or compression, how much force is there we can find from the principle of transmissibility. So to increase our speed of calculating force in the members in method of sections or method of joints, we will take the help of principle of transmissibility. You will save 15 or 20 seconds time like that. Okay, now we will try to solve a problem taking the help of principle of transmissibility. For some problems, principle of transmissibility may let you save say 15 or 20 seconds time. Some of the problems, if you do not know the principle of transmissibility, you cannot solve it at all. Now you see, we want to find force in the member KL, let us say. Let us say this is A, B, C, 30 kilonewton, 15 kilonewton, 30 kilonewton. This is the problem, let us say. We have 1, 2, 3, 4, 5, 6 panels. 6 panels at 4 meters. Let us say the total length is say 24 meters. Now, this height this 1 meter, this is say 3 meters. Okay, this is our problem. Now we want to find force in the member KL. Allotted time is a 2 marks question. You have say 1 minute, 1.5 minute time. Now by inspection itself, we can find the support reactions. Whether structure is symmetrical or not, 30, 15, 30 means symmetrically loaded. So you will get 37.5. So VA you will get 37.5 kilonewton. Vg is also 37.5 kilonewton. Hardly takes say 5 seconds time to detect. Now force in the member KL we want, we can cut it by 1, 1. You can take LHS of 1 1 or RHS of 1 1. So if I take C, these unwanted members are LC, BC. We don't want these two members, so we will take moment center about C equated to 0. Now you see, travel from tail to the head towards C, this is clockwise. Now it has to be anti-clockwise, otherwise it will not be in equilibrium. So this is force in the member KL. So clockwise, anti-clockwise balances. How you keep these arrows doesn't matter at all. So let us not keep any arrows in the first place. So this is what we have done. Force in the member KL. Cut it by 1 1. You take equilibrium of LHS of 1 1. Okay. Now take moments of all forces about C. Sigma MC is equal to 0. This is the sign convention. Clockwise positive, anti-clockwise negative. See here, VA first. Travel from tail to the head towards C plus VA into 8. So 37.5 into 8 minus FKL into this perpendicular distance. Force into perpendicular distance. This is inclined member. We don't know how much inclination. So perpendicular distance we don't know. If perpendicular distance if we don't know, actually FKL into D. If D we don't know, then you will use a principle called Varignon's theorem. What Varignon's theorem is? What he says is, moment of a force about any point is nothing but moment summation of its components. That means a force F is acting in some inclined direction, split into its components Fx, Fy. Fx, Fy is nothing but F only. So find moment of Fx about the point C, moment of Fy about point C. It is as good as moment of F about C only. So what he says is, moment of a force about any point is equal to moment summation of its components. That line is Varignon's theorem. First Varignon said, so it is named after him. So now FKL x component, y component, if I want to find, I must know the angles. This angle, let us say theta. Then what is theta? Tan theta is this height. From here to here it is 1 meter. This length is 4 meters. So what is tan theta? I will write it here. Tan theta is equal to 1 by 4. So theta you will get around 14.04 degrees. So you will split it into components. After splitting it to its component, FKL cos theta and FKL sin theta, I can take the principle of transmissibility to find the force only. Whether it is compression or tension we cannot find, magnitude we can find. What you have done is cut here, throw this piece out. Now KL can be replaced anywhere along its line of action. Its external effect about C is same. Moment of FKL about C, whether you keep it here or somewhere here, external effect, that moment is same only. This is the line of action of the force FKL. Why we have to replace this? If I keep it here only, say FKL cos theta, FKL sin theta. Two components are there. X component is going right side, I am putting it here. This is FKL cos theta. Whereas here, FKL sin theta. You see, if I want to find moment about C, means FKL sin theta into 4, FKL cos theta into 3. This height is 3 meters. 2 times I have to write and waste our time. If I pluck it and keep it here, say, along its line of action, this way, FKL, then what's Y component? FKL sin theta. This is FKL cos theta. I don't want here, I want to keep it here, say, okay, no problem. FKL sin theta. It can be replaced anywhere along its line of action. Even if I keep it here also, moment of this force about C is same as moment of FKL about C. That's the meaning of that. External effect of a force means moment. Wherever you replace force F, its a rotational effect about C remains same. Force into perpendicular distance only is the moment. So from that point, then if I replace them here, what's the advantage? What is the moment of FKL sine theta about C? See, FKL sine theta is passing through C, so it will give zero moment. Our headache is gone, half headache is gone. Only one moment you have to take it, FKL cos theta. So that replace FKL at K we have done. This is LHS of 1 1. This is what we are doing. Replace FKL by its components. By its components at K. How can you replace from the principle of transmissibility? From the principle of transmissibility. Now you will get plus 37.5 into 8 minus FKL cos theta into 4. Cos theta we know 14.04 into 4. Must be 0. So FKL you will get around 77.8 kilonewton. Arrow mark is towards the joint, so compression. Okay. Supposing that you didn't get this idea of transferring here only you want to get it say. So moments of two components you have to find about C. To that extent time will be wasted. So this is your second method. Replace FKL by its components at L as shown in figure. Now second take moments of all forces about C. Clockwise positive, anti-clockwise negative. Now you see, coming to this point. See here, when you cut here, throw this piece out. That means right side nothing is left with us. But still moments of these three forces about C we can find. Now after cutting and throwing it out, C is not no more a joint. C is some point in air. External rotational effects of the forces about any point in air also we can calculate, because that we are only finding rotational effect. It's not bending anyone, it's not twisting anyone. So this some point C in air. But about that point, if you want to find bending moment means not possible, because no member is there to bend. No bending moment, no twisting moment will exist. Simply rotational effect will exist. External rotational effect of a force. Okay. Now, when it comes sigma MC0 means VA into 8, FKL cos theta into perpendicular distance. This is FKL cos theta say. C is here. From C, this FKL cos theta drop, take your pen or pencil, whatever you have, put that pencil here. C is here. This is perpendicular distance 3 meters. Now FKL sin theta is acting vertically. So this is the line of action. Put your pen or pencil here. This is C here. This is the perpendicular distance. So FKL sin theta into 4. So now plus 37.5 into 8 minus FKL cos 14.04 into 3 minus FKL sin 14.04 into 4. FKL sin theta into 4 must be 0. See, two times we have to calculate this one. So FKL again we will get 77.8 compression. In the exam, if you are able to save in calculating the problems 10 seconds or 15 seconds say, it means you are saving lot of time. There in the examination only seconds will talk, not even minutes. So wherever you are able to save time means you have to save the time. Otherwise someone will go ahead by 15 seconds amount. Like that 4 problems means 1 minute he is ahead of you. That means we will be somewhere below 100, the above 100 rank only we will get. So much of difference. Okay. Now let us see a next problem. Now force in the member M2 U4. Say a problem is there like this. This is L1, L2, L3, L4, L5, L6. L means lower chord member, node, lower node we call it. Upper node U1, U2, U3, U4, U5. These are middle nodes. So M1, M2. Okay, there are total 6 panels. 6 panels at 4 meters. So 24 meters. Now this center one, middle joint, this is 1.5 meters, also 1.5 meters. Now this is the point. You have, it's one of the gate papers, it is asked as a 2 marks question. We have 1 minute time. What you are expected to do in the exam is this one. First you have to find, as in the first step, support reactions. Let us say V1, V2. In this case, the loading is not symmetrical. So we have to find what the support reactions are. Eccentric loading type is there. In SM, you have studied that if you have a simply supported beam subjected to some eccentric load, say this is A, this is B. VA is WB by L, VB is WA by L. That type of problem is this. It's like a simply supported beam. Whenever dealing with truss means, you must idealize that it's like a beam only. Only thing is beam action is converted into truss action with the help of link mechanism. So this is 8 meters now, this is 16 meters. So V1 you can take it as W is 180, B is 4 panels means 16, by L means 6 panels 24. So you will get 120 kilonewton. This will become 60. So we have spent say 10 seconds time or say 15 seconds time is exhausted. Now we wanted M2 U4. If I cut vertically 1, 2, 3, 4 are cut. U4 you take it 1, 2, 3, 4. So M2 3 members are there. So such cases you have to see the overall configuration I told you. One problem I told you that because of the symmetry of the structure, internal member forces are same and you broke that problem. In this case, now you see M2 L5. At M2 there are 3 members meeting 1, 2, 3. 2 are in line, so third must be 0. Somehow we managed to find M2 L5 that it is 0. Now headache is gone. Now if I cut it vertically by say 1, 1, 1, 1. So this is what we are doing. Cut M2 U4 by 1, 1. You can take RHS of 1, 1. That means you have to keep arrow mark on RHS of 1, 1 only. So cut here, look right side. We are not interested in U3, U4, L4, L5. These two we don't want. This already 0, only this I want. So since horizontal members should not come into picture, we have to use sigma y0. So cut here, look right side. Already 60 up. These arrows we are not interested. 60 up. Here it should be 60 down. This is FM2 U4. This angle let us say theta. Now this when you are writing sigma y0, upward force is positive, downward force is negative. When you write sigma y0, this is 60. So I have to write plus 60 minus M2U4 is not acting vertically down, it is going inclinedly down. Whose y component is M2U4 sine theta? F, I'll write here, plus 60 minus F M2U4 sine theta must be 0. What is sine theta here? This height is 3, this is 4, that means this length is 5. Sine theta is 3 by 5. 3 by 5 means 0.6. So Fm2U4 is 60 by 0.6. 100 kilonewton, arrow mark is away from the joint, so tension. So in 2 minutes time, our task is to cut it, detect that it is 0, then sigma y 0, that much. It's over. So you don't have to explain to anyone that arrow mark y it is downward, sigma y 0, again free body diagram, you should not write separate one and waste the time. So this whatever I have done, this way only you must solve the problem to save time in the exam. If you try, if things are not clear to you beforehand itself, in the exam also it will not be clear, you are spending more time say. If you say 2 into 10 is given suppose, then open the calculator, then where is 2 into 10 is equal to 20, then see the 20, okay 20 is correct. If you write like that, time is wasted. So we will not be in the picture at all. Okay. So the like this, Fm2U4 means 100 kilonewton tension, 100 kilonewton compression, 100 kilonewton tension also will be there. First to fix the arrow mark correctly. Suppose all are given compression, only one is tension say. You don't even solve this one, the tension directly will keep it. Because you know that arrow mark is away, it has to be tension. So process of elimination, everything will go off like that. Okay. Now let's see the next problem. We want to find force in the member AB. The truss configuration is like this. This point, let us say A, B, C, D, E, F, G. Now there is a load of 15 kilonewton, 15 kilonewton. The distances are given something like this, say 4 meters, 4 meters. This is also 4 meters, 4 meters. Okay. Now there are two reactions because the hinge support Vg, Hg, Vf, Hf. Now you see, in the beginning class I told you that links cannot take any shear force or bending moment. They are only axially loaded members. Now we want to know why they cannot take shear force or bending moment in this example. See, first we will take that concept. Note 1. Structural behavior of a link. Now you see, in this stress we will pluck out this DG member. DG member is now looking like this. This is G, this is D, length some L whatever distance is there. Now there are two reactions, Vg, Hg. Now to keep this member in equilibrium from sigma y 0, if Vg is upward, this has to be downward, Vg. If Hg is right side, here to keep in equilibrium, Hg must be left side. Link means no intermediate loading. Smooth pin here, smooth pin here. Now is it in equilibrium? Say sigma x0 satisfied, right side, left side. Sigma y0 satisfied, downward, upward. But still it is not in equilibrium because of sigma m is equal to 0. This force and this force together will form a couple. Couple means a pair of equal oppositely directed non-collinear forces. The only effect of such a couple is moment given by any force into perpendicular distance, some L let us say. So there is an anti-clockwise moment of Hd into L, and so it will rotate. So to balance that anti-clockwise moment, there should be clockwise moment. Who will give clockwise moment on this body? There is a pin here, bolt is there, here also bolt is there. Here the bolt says that I cannot give any moment. If you apply on the bolt any moment, it will rotate as a rigid body. It cannot resist the moment. That's what you have studied in strength of materials, the hinge supports. When you apply moment on hinge supports, moments they cannot take, the pin simply resigns and it will rotate, member will rotate. So here moment pin says I cannot give, this pin says I cannot give, then who will give anti-clockwise moment? This member, that is the free body diagram. At DRG, someone should give anti-clockwise, clockwise moment, otherwise it won't be in equilibrium. But you say that now this couple is not balanced. Now the truss is in equilibrium. Now how to keep it in equilibrium? Now for this member to be in equilibrium, Hg has no choice. It has to be 0. That is called link behavior. You ensure that you don't apply any load here. Then these two will be 0. If you apply any load here to balance this load, these reactions will develop and this link will bend. Such structures we cannot call them as truss structures at all. So that's why a link can only take axial force, either compression or tension, no moment, no shear force. Because connections are like that. We ensure that they are pin connected, not loaded at intermediate location. Then the free body diagram will tell you that they cannot take shear force or bending moment. Then that structure we want to call it as a link can take tension or compression only. Okay. So this conclusion if you want to write for this one. If any member is not loaded at intermediate location and connected by pins at the ends, it is called a link. It is subjected to axial force only. Axial force only means tension or compression. Bending moment is 0. In this case, if Hg is not equal to 0, then anti-clockwise couple. Anti-clockwise couple cannot be balanced. That's why bending moment is 0. So, in a truss, all members are links only. Truss consists of all such type of links only. That is the first, note 1. Second point is by inspection itself we should be able to find the reactions. Let us see from this diagram you will find that because it is an axially loaded member, so 1, 2, 3, 2 are in line, third must be 0. Next, Vg if you want to find, by inspection how we will find? Take moments of all force about F is equal to 0. Tail to the head towards F plus 15 into 4. This is minus 15 into 4. Net value 0. So Vg into 8 should be 0. So Vg must be 0. So Vg is equal to 0. Directly by inspection should write. You are not able to get it, say. Then you can write here like this. To find vertical reaction at G, this is the process. Take moments of all force about F is equal to 0. Clockwise positive, anti-clockwise negative. What will happen? Plus Vg into 8 plus 15 into 4. This is the force acting at B minus 15 into 4. It is the force acting at E. Must be 0. So Vg must be 0. But in the exam, so much we should not write and tell that Vg is 0. That's the point here. Otherwise, simply writing like this, then you may get the correct one, but who will give that much time? So this also became 0. Now having found both of them are 0, by inspection itself how to find forces in all members? First come to joint C. At C, two non-collinear members are meeting, CA, CD. two non-collinear members are meeting and no external load. As I told you, force in both members are 0. Next, come to G. If Vg is 0, it means that this also 0, otherwise sigma y 0 will not happen. So this is also 0. Take scissors, cut like this. So these three, throw it out. Now come to D. At D now, there are how many members? Only 2 members are meeting. So these 2 members, they have to be 0. This is 0. This is 0. Because at D, 2 non-collinear members, no external load. Throw it out. Now cut it, remove it off. Now go to A. Now you have to go to A. 2 members are meeting at A, no external load. So forces in both members are 0. Now come to E. 1, 2, 3 members. 2 are in line. So third must be 0. Over. Next, this is 15 down. To balance it, it should be 15 up. If arrow is away from the joint, here also it should be away from the joint. Over. Next, come to VF. See, in the entire truss, 15 down, so it has to be 15 up. Entire truss 15 right, so it has to be 15 left. Next, this angle of inclination 45 degrees. Now you see here, this is 15 up. To balance it, it has to be down, because this horizontal force will have no influence on the vertical component. If this is upward, means it has to be downward. Or if you see this one, say, if it is acting left side, it should act right side. And which way we can see. Now you see this value, F sine 45 must be 15. Some force F into sine 45 is the vertical component. Minus F sine 45 plus 15 is equal to 0. So F is 15 by sine 45. That means 15 by sine 45 means 15 root 2. In the exam, first you write 15 by sine 45. Next line, sine 45 is 1 by root 2. Then back substitute. Then you write it as 15 root 2. Means time is gone. Towards the joint. So here also it should be towards the joint. So why one member entire truss analysis can be completed in 1 minute time. In the exam, questions will be given such that you will be able to complete in 1 minute time by inspection itself, or at the most one line you have to write. Okay. So this is, now you understood in a truss why the members cannot take shear force or bend moment. Here for example, I have taken this one, I can take this also, or this member if I take it, say, plug it out, draw free body diagram, both ends pins. Okay. So sigma y0, sigma x0 you can satisfy. Sigma m0 if you want to satisfy on that free body diagram, any force you write, say, in the perpendicular direction, then those two forces will form a couple and it won't be in equilibrium. So that member free body diagrams, any member you take it, that free body diagram tells you that it can only take tension or compression. Okay. Now, in the beginning of class, I told you about a concept called counter bracing. Now that you have understood method of sections also, counter bracing, how it acts, let us see. counter bracing. This type of truss we call it as N-type truss because it is in the shape of N. N-type truss or Pratt truss. Pratt truss. Because from the beam action to truss action, when I have explained to you that slicing Pratt, I have told you that beam they have replaced it with the help of links. First man who tried to convert beam to truss is Pratt. So that's why this configuration itself is named after him. So first he tried with N-type configuration. So it is named after him. After that, the Warren has come. He has tried with triangle configuration. So that trusses are called Warren trusses. So those are the days where first they are the ones who tried to experiment with the link structures. So that's why it is like that. Then later on people found that the disadvantage of the Pratt truss. Supposing that this point, this is VA, this is say VB. As I told you, this is 4 meters, this is 4 meters, say this will be 4 root 2 meters. So long a member. What happens because of that is they will buckle. People found that they are buckling and failing. Supposing that if I take a section XX, I told you shear force at XX is called panel shear. Now what is the panel shear at XX? Assume that loads are somewhere here, here load is not there, only VB is there. So upward force, to balance it, it should be downward, F. Now you see, you have a diagonal member subjected to a compressive force F. Due to some reason here the loads were so high that unexpected extra loads came. VB is also very high, now F also will be high. And because of that this member buckled. If this member buckles, then what will happen? All the members are safe, only this member fails. Once the member loses its straight configuration, we say that it has failed. So if it buckles, then who will take that panel shear force F? Since now this will become like a square link construction, it becomes a mechanism. Immediately entire truss will fall down, then collapse. To prevent such collapse of entire structure because of one member, we add one additional member like this, like this. Now you see, this first both members will take some load. This takes 30, this takes some 20, like that they are taking, say. In case it fails, instead of 30 it becomes 60, suppose. But tensile force is 60 kilonewton they can take. Why tension? Once this fails, let us say, cut here, look right side, upward. Now this arrow must be downward, some F1, let us say. Then what will happen? If there is a compressive force, there is a tendency to buckle. If there is a tension, no question of buckling. Compared with compression capability, if the cross sections are same, tension members can take at least 2 to 3 times additional force. Why they can take so much high force is the no buckling problem. Okay. There is some other problem called, we will see in the later steel structures, shear lag, etc. The design problems are totally different. Since there is no buckling, you till the break you can load it. So that's why tension force they will happily take. So panel shear is resisted by this diagonal member. Supposing that due to some reason of reverse loading comes like this, VB downwards. This is say tension, this is under compression. Due to some loading, if this buckles, then this will take the entire tension. So one is a counter to the other one. One member fails, other will take care of it. So such additional members in each panel you have to add one because there is a possibility of failure. Such additional members we call them as counter bracing. But to overcome this disadvantage, later on people what they tried was instead of this type of trusses they are using K type trusses so that the diagonal lengths will not be so high. If you attach them like this, say, now diagonal length full it will not run, it will run like this. So diagonal length is less. Instead of providing a counter bracing, people started using K type trusses. So this is the conclusion. Especially this type of things will be useful in our interviews. If they ask you what is the disadvantage of prod truss, you should be able to tell that the disadvantage is that diagonals may buckle. To overcome that disadvantage, you have to use the counter bracing. If you don't want to use counter bracing, use K type trusses. This is the explanation we should give. The disadvantage of prod truss is that if the length of diagonal is more, it may fail due to buckling. That buckling is due to compression. Then panel shear in that panel is not resisted by any member and truss collapses. To prevent collapse of entire truss, additional diagonals are added to each panel. These additional diagonals form counter bracing, or these additional diagonals are called counter bracing. So if one member fails, other member will take care of the stability consideration. But in the process what happens, the truss becomes statically indeterminate. Then you have to take indeterminate truss analysis by taking stiffness matrix method or energy methods. Then you have to find the forces. Why should we make indeterminate? Otherwise the truss collapses. So make it indeterminate and analyze it. We know how to analyze that. There is a problem that it may fail. So what to do? We have to solve that problem. We solve the problem by adding additional diagonals and make it indeterminate. So we cannot throw the structure. We have to use it means we have to use additional diagonals. So otherwise you have another possibility is K-type truss. So length of diagonal is not more. The question of buckling possibility is less. So this is about the counter bracing where I have given, so that only number of members are more than 2j minus 3. You have to provide more than 2j minus 3 in some cases to prevent collapse of the entire structure. Such cases, it becomes internally indeterminate, then those additional members we call them as counter bracings. Okay. So this is about complete information regarding the method of sections. Having understood this point, now the second important aspect is the deflections due to loads. If it deflects more, then it becomes useless only. It should be sufficiently strong to take the loads. It should be sufficiently stiff not to deflect too much. If it deflects more, sometimes the equipment may collapse, may overturn and fall down, and the people who are working will not feel comfortable. So, to know how much it deflects, first we should know how much it will deflect, then only controlling the deflection will come. So, to find the deflections in the trusses, we take the help of strain energy method or unit load method. Okay, that we will see in the second topic, analysis of trusses using or say deflections in trusses in deflection trusses using the strain energy method or unit load method. Okay. Okay. Now to reduce length of diagonals, we can also use this K-type trusses. So K-type trusses are the modification of that N-type trusses. So diagonals will not be too long. Failure will be minimized.